All right. Well, good morning or good afternoon, everyone. We're at the top of the hour. We'll get started here in just a minute. So stand by. Okay, I'm seeing some more folks trickle in here. This is good. So we can go ahead and get started. As I said, good morning or good afternoon. This is a webinar produced by Particle. My name is Andrew Lund. I'm a product marketing manager here. Today, we're going to discuss the role of IoT in distributed air quality and emissions monitoring networks. Bit of housekeeping. So the Q&A function is enabled. So please do chat in questions as we go. If we're not able to get to them during the webinar, we'll get to them in a follow-up email communication to you. I'm I'm actually pretty excited about this morning's webinar. We have a couple of folks on who are very experienced, very knowledgeable, and it's my honor to introduce them. So let me welcome Michelle Polino. Michelle's a principal analyst at Forrester, where she leads Forrester's edge computing and IoT research practice. During her tenure at Forrester, she's advised leading Fortune 100 and 500 companies on their edge IoT strategies and has been frequently cited in major news outlets, including several that you can read on her bio on the registration page. I won't go through them. Michelle's got a lengthy bio, but thanks for joining us, Michelle.
Thanks so much. It's a pleasure to be here.
And also joining us is David Hagen. David is the CEO and co-founder of QuantAQ, a market leader in the distributed air quality sensing space. So David holds a bachelor's degree, a couple of bachelor's degrees in chemical physics and one in chemical engineering, as well as a PhD in atmospheric chemistry and physics from MIT. So welcome to you as well, David.
Yeah, thanks for having me here. And I'm excited to have this chat.
Yeah, for sure. David and I spent quite a bit of time together last week, actually, at a conference in the UK. And if the audience learns a fraction of what I learned from chatting with David and then from Michelle over the last few months, it'll be time well spent. So let's get into it. Michelle, I want to kick it off with a question to you. And I think, given the fairly comprehensive nature of the work that you've done at Forrester, you'd be a good one to maybe give us some context for how we should be thinking about the way that IoT technology is used to meet sustainability goals in different industries.
Yeah, that's a really good point. And if we go to the first few slides, I'll give some context to what we're thinking at Forrester within the looking at this overall evolution and momentum that we're seeing in the air quality environmental monitoring category. And what's really clear right now is that there are many factors that are driving the focus that organizations are having at a city level, at an industry level, even in doing additional research in this area. And partly because we know that there is an increased understanding that more and more issues that are happening around pollution and air quality can impact the health and well-being of individuals, whether it be different types of diseases around COPD or asthma or different types of heart disease issues. This recognition of the linkage between poor air quality and having a poor oral health. The other thing that's happening is that there's expanded government policies that are coming from both federal level at the EPA level, certainly in the US, but also at other global governments that are forcing this issue, and indeed at the local and regional level, where many organizations are trying to position, the value proposition of what they're doing with respect to issues around sustainability and contributing, to enhancing the air quality, reducing carbon emissions, and all these types of initiatives that are really under the broader umbrella term around sustainability. Now, if you think about going to the next slide, I wanted to give some context as to what we mean. Sustainability is a term that has a lot of different components to it. And when we think about the priorities that many organizations can have with respect to their sustainable initiatives, you see kind of a categorization of some of those types of initiatives here. Some are more tied to developing products and services and the life cycle of those products in a more sustainable way, in the materials that are used and the types of circular economy initiatives that are happening. When it comes to air quality, though, it really fits into the category of environmental resource monitoring primarily. And this is when organizations are using different types of technologies, and I'll talk more about how IoT fits in here, but using these technologies to really better understand the use of natural resources like water or power or energy, as well as to monitor the environment. Air quality, carbon dioxide monitoring, emissions as well comes into play in those types of sustainable initiatives. And then from an operational side, we also see different critical processes that are becoming more sustainable depending on the organization and the kinds of activities they're involved in, the critical activities and processes. They may be trying to be more sustainable in how they manage their supply chain or how they're dealing with different types of product manufacturing processes, or even in more building and facilities management. And certainly around building and facilities, you see air quality being a piece of that, or even in the industrial manufacturing processes, understanding what's happening in those buildings where manufacturing is done, or in those environments if it's in oil and gas fields as well. So that just gives you an idea where sustainability, air quality monitoring, all becoming very important here. As we get on to the next slide, what we're also seeing is almost a convergence between the focus that I just mentioned around being more sustainable, understanding what's happening with the different types of issues that might be happening with air quality, and bringing that to a more city-specific level. And sort of merging these two ideas, we have what's really focusing many cities on in identifying their air quality at a very localized level, at a neighborhood by neighborhood or even a block by block level, and improving the quality of air and certainly monitoring it, because there are disparities between certain neighborhoods, certain blocks, even in the same city. And some of the cities that are being more proactive in really bringing together these types of initiatives to really enhance and do a better job of monitoring air quality are in Charlotte, North Carolina. We see examples in Louisville, Kentucky, in Washington, D.C., and Indianapolis, Indiana as well. And some of the things that are really helping these types of initiatives move forward are tied to examining the connection between the quality of air in that more regional and local specific, or even block by block specific nature, with the resident health, as well as to bring to light more granular maps of what's happening with air quality, making alerts happen and telling folks that maybe the air quality where they are is not great, so maybe they want to stay inside. And to enable these solutions, you have a combined, public, private, and even academic partnerships to really help these initiatives move forward. So if we go to the next slide, one of the things that we're seeing is that it's not just about cities becoming, more focused on what types of air quality they have. We do surveys at Forrester to better understand adoption of technology such as Internet of Things solutions and the plans that organizations have for using IoT solutions to help them implement certain types of use cases. And in this case, we're talking about environmental monitoring. And when we talk about environmental monitoring, our definition includes indoor and outdoor air quality monitoring, pollution monitoring, and those types of activities. So fits within this overall umbrella of air quality monitoring for the focus of today's session. And what you see here is that question that we asked of global stakeholders that are part of the decision-making process and understand what's happening around their IoT initiatives. We cut that based on industry. And you can see there's proactive government organizations are certainly implementing IoT solutions in environmental monitoring, but you also see more specific industry focus around production processes, industrial product manufacturing, or even in specific industry sectors or environments in oil and gas and chemicals. So lots of different opportunities to leverage air quality monitoring at both a city level to address sustainability, as well as to enhance environmental monitoring in these different industry environments. And I think I'll just wrap up with this last slide, which really highlights the fact that these environmental monitoring solutions can extend into many different types of environments or assets in those environments. And so what really ties into the discussion today, some of the public spaces or workspaces, you could use air quality monitoring as part of those IoT solutions. You can incorporate these air quality monitoring solutions in different types of landscape environments, outdoor environments, parks, different common areas. And as well, incorporating these types of solutions for air quality monitoring in indoor building environments. So whether it be in office spaces or in warehouses or in factories, all kinds of examples where building environments could also benefit from these types of IoT environmental monitoring solutions. So I hope that gives a bit of idea to the audience as well as to what we're seeing in some of our survey data with respect to using some of these different use cases.
For sure. Yeah. Thanks, Michelle. Yeah, this is interesting. And I want to transition to a question to Dave for a second, but we had a few folks come in maybe after I had said, look, our Q&A function is activated. So shoot questions to us. We'll either get to them or address them in some follow-up communication. But it's not every day that you have one of Forrester's lead analysts and a CEO co-founder and MIT PhD like David on the phone. So it's a good chance to take advantage of this. So summarizing kind of a little bit of what you had said, Michelle, I'm hearing you talk about, okay, there's an expanded demand for environmental monitoring technologies, ways that IoT is being used to address those. But then a little bit more specifically, you got into some comments about air quality being used at a much more local level, which is interesting. That kind of dovetails into a little bit of what our next guest here, I think, will talk about. So, David, I wonder if you could, I wonder if you could give us kind of a little bit zoomed in view of air quality monitoring, a layperson's view, if you will, on the industry and the science, and yeah, maybe how that's evolved. So.
Sure. Yeah. So yeah, you can go to the next slide. Yeah, I'll just start off with kind of talking a little bit about why we care about air quality monitoring and why it's so important and how it's been done for the last 50 plus years and kind of where it's going, or at least where we think and hope it's going, both as a company and as an industry as a whole. But as you can see here, this is just some data from the Global Burden of Disease. This is a few years old. I stole it from my dissertation. Didn't have time to update it to current numbers. But if you consider all, even within environmental monitoring, as a whole, air pollution is, by far the leading cause of both death as well as kind of general sickness, as measured what are using called disability adjusted life years. And so this has actually become a little bit more pronounced over the last few years of data, to where air pollution now leads to more than 7 million deaths, early deaths or premature deaths annually across the world. So go to the next slide.
Before I do that, David, what's the second bar there? What's WASH?
WASH is general hygiene.
Okay, fair enough.
Yeah, and so when we think about measuring air pollution, air pollution means a lot of different things, or is composed of a lot of different things, some of which are biogenic in nature. There's a lot of VOC emissions and natural dust that is kicked up and transported across the globe, as well as wildfires, some of which are biogenic and natural in source. Some obviously are heavily influenced by the changing climate and kind of human use of the landscape. And this kind of just shows a little bit of all the different types of sources and general life cycle of stuff in the air. It's unfortunately not as simple as just, your car emits X, Y, and Z and it goes up and floats around. There's a lot of chemistry that happens, which makes it more complicated to understand maybe where some of it is coming from. There's a lot of statistical work done to identify the primary types and sources of pollution. It's also interesting from a purely scientific basis. There's a lot of oxidation chemistry that happens. And if we go to the next slide, if we think about air pollution on a global scale, so this map shows specifically PM 2.5, which is fine particle pollution, stuff that's under 2.5 microns in diameter, across the world, where yellow is the worst or the highest concentrations. And then the little black dots are publicly available reference grade monitoring sites. So stuff that's operated by the EPA, the UK Met Office, or similar organizations across the world. And then 12 micrograms, or now about 10 micrograms per cubic meter, is the kind of the WHO's guidance for where PM 2.5 should be. So anything below that is within the guidance, anything above that is not. And 91% of the global population is at greater than 12 micrograms per cubic meter. So that's a problem. And the bigger problem is that we see very clearly that we have an inversion between where we're making measurements and where the problem is the most pronounced. And that's largely because the United States and Western Europe enacted the Clean Air Act in the 70s and have done a pretty good job at least in improving monitoring at the regulatory level. But there's a long ways to go. And if we go to the next slide, we will see that it's not just at a global scale or a country scale or even a regional scale. It is, air pollution is incredibly heterogeneous, both in space and time, on even a neighborhood scale, as Michelle alluded to a little bit earlier. And so this is some data from EDF looking at, I believe, San Leandro in California, just showing, I believe the data here is for NO, so a combustion tracer. And you can see very clearly that over time, the highways or the heavier roadways see a much more pronounced exposure to this type of air pollution than what the regulatory framework is really able to capture. So if we think, taking a half a step back, at what the EPA's role is in monitoring air pollution, it is really to ensure that regions of the United States are in compliance, largely. And that is what the regulatory network was really designed to do, was to make sure that the Northeast United States was in compliance, or California is in compliance. And so often we're looking at how longer term trends. Over the last 50 years, we've learned a lot about just how heterogeneous air pollution is, both in space and time. And we actually have the ability to at least potentially make changes in real time. And so moving to a monitoring framework which allows us to make not only more spatially resolved measurements, but also more temporally resolved measurements, we can actually integrate with whether it's building controls like HVAC, or other devices, or even alert people in real time. We actually have the ability to make rapid changes to reduce people's exposure, which isn't currently possible with the regulatory framework.
So, okay, but I guess the thing that's, I'm curious if we can dig into this a little more, because you talked about the Clean Air Act 50 or more years ago. There's been I mean, we're kind of post that initial Rachel Carson Silent Spring green, I don't know, green revolution, or sort of initial exposure to public exposure to environmental problems, public concern about it. A lot of action's been taken, a lot of money has been spent on it. And there are agencies that are doing things to address this. But there's apparently, I mean, you see an opportunity to address this in a unique and kind of like differentiated way than how others are. And I wonder if you can lead us down a path to show like what your specific, what QuantAQ and QuantAQ customers are doing that's different here.
Yeah, I don't remember which slide is next, but yeah, there we go. Great. So, traditionally, air quality monitoring, especially at the regulatory level, is done with, on the right-hand side here, what we're calling regulatory instruments. So these are, expensive, large, power-hungry devices that are very good. They're very accurate, precise. They've undergone rigorous testing and validation over the last 50 years. But they're, both economically and physically limited in how many we can distribute across the world. And on the other hand, over the last 10 years, especially with the rise of kind of personal electronics and Arduinos and Raspberry Pis, there have been a whole host of consumer grade sensors that have come onto the market, and that's great. And it allows people to, learn a little bit and participate in making measurements. And there have been a number of very successful environmental monitoring projects that start at kind of the consumer level. We sit kind of in between. And so, me and my co-founder, we're both, scientists and engineers, both PhD atmospheric chemists. We came at this from, starting at the regulatory level and saying, okay, how can we build a device that is, almost as good, but then drive the cost as close to the consumer side as possible, rather than say, start with a consumer device and try and, add, algorithms to it to make it slightly better. Our goal is to produce, actionable, reliable air quality data that people can actually use to make, not life or death decisions, but, important decisions about either what their exposure is or, how to manage various things, whether it's buildings or construction sites or other forms of other things that might lead to emissions and increase in exposure for other people.
Okay, so you used a phrase with me, and I want to kind of I don't know, maybe springboard off of this phrase. As we were talking about this last week, it might have been, I think it was last week, this phrase, which you had mentioned for like construction sites or quarries or mines, with national parks, supplemental air quality monitoring. Can you maybe explain to the rest of us what you were meaning by that?
Sure. Yeah. So the EPA and the regulatory network, the National Ambient Air Quality Monitoring Network, operates, I think, on the order of 2,000 to 3,000 sites across the United States and islands. And each of those costs on the order of $500,000 to $1 million in capital costs. They're physically large, and I'll show a picture in the next slide. I can show it. So this is what one of those monitoring sites looks like, right? It's physically large. It's permanent or semi-permanent. It requires a ton of power, air conditioning, a full-time technician to go, manage a few sites to calibrate equipment, make sure it's good, goes through rigorous QA/QC processes. And if you go back to the previous slide, and that's great, but there are a lot of instances where we don't need data that is that high quality, and certainly not on a per cost basis. And so, with, a device like this, which is our modular RPM, which is a particle sensor, we can build physically small, this device is less than a watt in power draw that can go pretty much anywhere. And with, the LTE connectivity, these can be deployed across the world easily. And so we can, the Government Accountability Office wrote a report a few years ago that recommended, on the order of 100 plus of these types of devices around each one of those 3,000 EPA sites to increase the the spatial and temporal resolution of the monitoring network in a way that allows us to get good enough data, but doesn't necessarily break the bank.
That's great. That number 100, it's like 100x what's out there today. In a sense, it's like dropping that in. That's it gives you a sense of like the scale or the size of the opportunity, not I'm talking commercially, but just how valuable this must be to that, like the regulators and scientists and like experts, that's super cool. We're going to take a little bit of a risk here, but I'd like you to take us a little bit deeper into the platform itself, like the QuantAQ modular platform, a little bit of how it works. Again, the audience for this webinar is obviously a little bit self-selecting, so it's not like this is general public, but if you, I think you have some slides on that right here.
Yeah, I don't know if they're the next ones, but we can take a look. So,
cool.
So what we do, at our heart, we're scientists and technologists. We do a ton of work on the instrument development. So, we've designed and built our own, particle sensor that measures particles in a fundamentally, unique way that gives us, better data at a low cost. And then on top of that, we do a lot of, fun, basically, machine learning and AI to both improve individual measurements as well as identify types and sources of pollution. And so that was straight out of my PhD was, how can we do some of these unsupervised learning techniques or factor analysis to actually identify, not just that carbon monoxide is higher now or PM is higher now, which are very useful things, but actually take it a step further and get to, where is this coming from? Is it coming from a combustion source? Is it coming from, this other, type of pollution? And that's important for a lot of reasons, some of which are regulatory in nature. Can we identify what the dominant sources are so that we can, clean them up? Many environmental sources of pollution, whether it's water, air, or soil, are often dominated by a few bad actors. And so, for diesel trucks, for example, something like 95% of the black carbon pollution comes from 5% of the overall fleet. And so you don't actually, at the regulatory or the, enforcement side, you don't necessarily have to retrofit every single vehicle or every single truck. If you can just find the ones that are polluting the most, you can, in a very cost efficient manner, clean up the problem, which leads to these massive health, benefits, as I showed in that first figure.
Yeah. Awesome. Okay. Take us talk to me about dual detection technology for a minute here.
Sure. So this is just a little bit about what separates us from our competition. And so on the particle side, there are a number of both consumer grade devices and other low cost particle detectors that are available on the market to measure particle pollution. Some of which, fall into all of them are light scattering based. So they use a laser or an LED to scatter light off the particles. You then capture that light and correlate that to either a total concentration of particles or the size of the particles. And so what we do that is unique is we combine two different types of light scattering devices and overlay the spectra to reduce the uncertainty in each individual approach. So that allows us to get, very high quality data across a wide range of size ranges or types of pollution for a very low cost.
Interesting. And I should mention that in a strange twist of fate, particle industries is different than the PM particulate matter. It's just kind of a funny coincidence. But this Yeah. Okay. So, Michelle, let me ask you the next kind of question here. So, thinking about what you had shared about the number of different like opportunities to use the like IoT technology, and then combining it with pretty pretty rigorous leading edge like science, which essentially is what David's talking about, to then deliver a solution to the market. How, and given your experience in this and so forth, if someone came up to you like at a party, okay, and said, "Hey, Michelle, I heard you work for Forrester. You know a lot about this IoT stuff. I've got this cool idea to build an environmental monitoring solution using, LTE to send data to a cloud and present it in a dashboard, whatever." And they kind of just pitched you this an idea, okay, just generic for the discussion's sake. What would you like? How would you respond? What are some maybe common pitfalls you would want them to avoid, or guidance that you would give in that kind of scenario?
Yeah, it's a really good question, because the thought process around Internet of Things it's three words, but it's many different technologies, and there's a lot of fragmentation in what has to come together for IoT solutions. And so if you go to the slide that we kind of use to represent what has to come together for an IoT solution, and recognizing that's not a standard definition. So we define IoT solutions as providing software control of the physical world, or bridging the physical world with the digital world. And when you start thinking about doing this, you'll see some of the things that David was talking about in the kind of solution capabilities that you need to bring together, and the technologies that are part of this. So at the basis of this, you have those sensors, the different kinds of accelerometers, GPS capabilities that are incorporated into the many types of devices. And those sensors are connecting into the LTE, the 4G, the 5G networks, the other types of wireless capabilities, or other industry-specific infrastructure as well. And they capture information about location and status and particular, composition, as we were talking about. And that information then is brought to light using analytics capabilities, machine learning, AI analytics, different types of algorithms, to really better understand what now is an option or an alternative that could be taken based on that insight. And that alternative action could be identified on a dashboard. It could be identified in an alert. And the action itself, once it is identified, can be taken in a true machine-to-machine way, or the alert can be sent to a person so that that person can pay attention right at that moment to whatever is going on. So if there's something particularly bad going on in the environment, maybe there's a fire that's causing problems because it's a 4-alarm fire in a neighborhood, what action should be taken next? Is there some alert that could be sent out? And then identifying elements of security wrapped around all these connected environments, and realizing that you have to think about deploying these solutions in cloud environments or different edge environments. All of this has to happen on an IoT use case by use case basis. And we've been talking about it from the perspective that David's brought to light, which is how to deal with this with respect to air quality monitoring and the efficiencies that can be gained with the solution he talked about. But there are many use cases in IoT, and this kind of these elements all need to be thought through. So that's one thing. When someone talks to me about IoT, I say, okay, let's get on the same page as to IoT is not one thing, right? So it's not one thing, it's not one use case from the tech use case side of it. The other thing, as we go to the next slide, would be thinking about it from the perspective of, well, who has to be part of deciding, which of these use cases, what kinds of solutions are going to be most relevant in my organization, in my city. And oftentimes you need to be sure that stakeholders that understand the problem, which are usually the operational stakeholders, are also participating in requirements, in use case identification, in deployment and implementation, along with the IT stakeholders. Because the operational stakeholders understand the problem, they understand what's going on, the challenges that are being faced by the environment around air quality monitoring, environmental monitoring. What sorts of KPIs do they need to meet? What kind of goals do they have? And then the IT stakeholders understand, okay, we need to scale this. We need to understand how to ensure this is secure. We need to ensure this interfaces with some of our existing environments in the cloud or for back-end systems that need to bring us legacy information to light. And the other thing you have to think about once you sort of think about deploying this with IT and OT collaborating to do that, you can recognize that the information that's captured from the connected environment really addresses needs from many different types of stakeholders. So it may not be that it's just about the sustainability stakeholders that can get value from this. You can have stakeholders in the operational side of the business, on the site, folks that are in the operational processes or in the utilities environments, or stakeholders when we're talking about cities who represent the civil servants and the folks that are visiting, or citizens or residents, as well as the folks that are involved in legal and compliance issues when you're trying to address regulatory requirements that somebody like the EPA is putting into place around some of these areas. So recognizing that all that information and insight needs to then be translated in a way that can be useful to many stakeholders is also very important. It's not just about the sensors, it's about the insight. And this is a really important part of the puzzle when you think about IoT solutions. Now, the other thing I think is important, Andrew, is as we go to the next slide is, it should be pretty clear now that deploying these solutions is not as simple as it may look. I mean, we have these nice little pretty pictures here, but when you start thinking about deploying these solutions, the fragmented array of connected devices, the many different types of networks, we're talking about LTE networks and emerging 5G networks, Wi-Fi networks, possibly industry networks, there are many different things that have to come together for an IoT solution to be deployed seamlessly. And there's a category of a solution called an IoT software platform that can help to simplify the complexity of deploying these initiatives. And we have identified 5 key functions that these platforms can offer in order to deal with this array of these connected environments and devices and the analytics and the capabilities that need to be deployed and brought to light using IoT solutions. The first function here is about connecting on a scalable level the many different devices, so that as you have hundreds, thousands, many thousands of these connected devices, you need to be able to activate them. You need to connect them into the various environments, the different networks they may be connected to. You need to understand how to manage the ongoing software that's deployed on those devices in a seamless way. You're not thinking about just, activating and deactivating. You need to update software, and make sure everything's being using the same version of that software, and to manage the issues that may arise if there is something that goes wrong in that update process. You also need to think about security issues. There's security issues that happen here all the way from the network side of the world into the devices, in securing the information that's captured and and who gets access to that information. And then you have to think about how you're going to bring to light that information in valuable ways using, cloud capabilities, using AI and machine learning, and even real more basic analytics capabilities, integrating with traditional legacy insight and data, bringing that information to light with the real-time data that's coming to light with the IoT solutions. And then finally, you need to figure out how you're going to help the developers incorporate these capabilities into the new services that they can offer. So this is using like APIs and different kinds of interfaces that help, get the tools for developers that get them going in a quick and efficient way. So lots of things going on with these platforms to align with the fact that a lot of elements are coming together when you're deploying these solutions.
Yeah, there's a lot there. Let's go back to our friend at the party. I think you've got like I think you distill this down into a few kind of a checklist almost, right?
Yeah, and I think that's what I'd kind of wrap it up by saying, okay, so maybe you're already starting on your path, and maybe you already have what I would call a do-it-yourself platform that does some of those functions that I was just talking about to help you along your deployment initiatives. But as you start thinking about, well, do I continue to want to do this myself, right? Do I continue to want to create those functions around connecting and managing and bringing to light this data in new ways on an ongoing basis? We have to think about that. This is not a one and done kind of thing. You have to have ongoing maintenance and updates of those interfaces, of those APIs, of the platform connections into cloud environments. And so it's not that simple. And do you have the right skill sets in-house to do this? So where do you want to, really focus your investments and your personnel? As so lots of things to think about, because I think that the way we think about it at Forrester is that oftentimes using a platform solution is definitely much more efficient, effective, and allows you to focus on the issue or the use case you're trying to solve, as opposed to all these other elements that have to come together for that solution to work seamlessly. And the other things that you will see on the other points here, many of these things are tied to the value that that platform offers. Can you enroll these devices, at a scalable level into many kinds of networks, depending on what types of network connectivity is needed? Are you able to control and manage the updates of the software and the depatching that might need to happen on those software-enabled capabilities? What about securing and scaling these solutions over time? We aren't just talking about a few hundred. Over time, as David was saying, you're going to have thousands, many thousands of these connected environments that need to be managed. And ultimately, what about the role of the cloud here, bringing to light AI and machine learning capabilities, other kinds of cloud functions that can be valuable and brought to light for some of the analytics solutions and insight that we were talking about. So a lot of these different things are things to think through, where organizations may have started down that do-it-yourself path, but ultimately, if somebody was asking me this at a cocktail party, of which we might have had a few drinks by then, but ultimately, I would say you need to think more strategically about what you need to do, because doing it yourself may not ultimately be the best answer here. Ultimately, these platform solutions from a third party may well be the better option as you think about your strategic initiatives over time.
This is great. Yeah. Very cool. Okay, so we're coming up on our time here. I was going to ask you one more question, David, because when I when I think about what you're doing, and I think about that map that you showed, where kind of that the concentration of sensors in areas where the air quality is I think PM in that particular case was relatively lower, versus this absence of sensors where it's needed, and the fact that we all have lungs, and so we all care about air quality, whether we probably don't think about it day to day. I'm really grateful for what you're doing, and I wonder if I kind of find myself thinking, like, okay, thank goodness Quant AQ and David's team are taking care of this. If I was to turn that question around a little bit, though, and say, okay, is there anything in your solution, right, that Particle has been particularly helpful with or useful, and as you partnered with us, where you say, man, thank goodness Particle takes care of X, Y, or Z kind of thing? How would you respond to that?
Yeah, I mean, as Michelle pointed out over the last few slides, running an IoT platform and allowing people to get connected to the internet via Wi-Fi or LTE or NB-IoT or whatever it is, and then managing all those devices in a way that is, kind of production grade, secure, and all of the things that go with that is a ton of work. And we bootstrapped our company for the first 3 years with people. I'm an engineer, but I am not a wizard on the the connectivity side of things, and being able to focus on the hardware itself, or the sensor technology itself, and the science, and making that as useful as possible, and not having to worry really at all about how are we going to get this data from the device to our platform is incredibly valuable. I think about it or equate it to, the same way we do for servers. I could go to Micro Center and buy a bunch of servers and we could run them, in our lab and do things that way. But I am more than happy to rely on Amazon or Google or, IBM to run their cloud and to allow me to lease server space so that they are always kept up to date. They're always secure. They're investing, millions and millions of dollars in making sure that everything is secure and operational. And I think that's, a huge benefit on the particle side. I mean, literally allowed us to not hire, probably 2+ dedicated people, on the engineering side to do this at the beginning. And that is, it allowed us to exist.
Cool. Super cool. Well, thank you. Hey, listen, let's wrap up here. Michelle, where can people go to learn more about what you're working on?
Yeah, I mean, certainly all the research that I do and my colleagues are doing in some of these key areas, especially I think around sustainability, is one thing I would just call to mind at the Forrester website. And one of the things that's coming out soon over the next few weeks are our predictions for 2023. And some of these predictions are tied to what we've been talking about today around what's going to happen around sustainability, what's going to happen with respect to IoT and edge and these types of networking initiatives that we've been referencing. But we also have predictions that are focused on particular industries around what's going on in manufacturing or healthcare or overall in the cloud. So I'd encourage folks to look. There will be blogs in those areas, there's reports in those areas, and there'll be webinars in those different predictions categories. Pretty exciting for us as analysts each year. So
yeah, it's like that's super cool. Thank you. David, same question for you.
Yeah, so I mean, just generally we have, I don't know if you have the blog side, but we don't have any product announcements right now, but we do have a blog that you should all subscribe to if you care about learning both about particles and air pollution, as well as just random engineering tidbits that we discover or develop along the way.
Awesome. Yeah, super sharp team at QuantAQ. I highly recommend that. And I've loved reading Michelle and her team's work too. So thanks again to both of you for joining us. Thanks to our audience for joining us. Hopefully this was useful. There was a really good question, actually. Someone had asked about the regulatory impetus and for more activity and investment in this space through the Inflation Reduction Act. We could also talk about California's Assembly Bill 617. There's some really cool there's funding available. So in the follow-up, I'll see if I can summarize an answer to that question. But yeah, thanks for joining us and have a good rest of your day.